Thank you for attending my session, TensorFlow in the Wild. I'm Sato. I'm a developer advocate for Google Cloud Platform. So a developer advocate means it's like an evangelist for developers. So I usually attending the events like or the meetups and talks about our products and technologies. And focusing on data and analytics products such as Google BigQuery, which is a data warehouse service from Google, or the TensorFlow, which is the machine learning library I'll be talking about today. So today I'd like to cover these topics. At first, I'd like to show a very short introduction and demonstration of a neural network, what is neural networks. And then I'm going to talk about the TensorFlow, what is it, and how Google has been using it, and how the Google community and ecosystem is using that. What is neural networks? How many people have tried neural network? Oh, I see. Okay, looks like it's like less than 10%. I always ask these questions, but this is the average. If I go to the web developer conference like this, usually less than 10% has actually used the neural networks. But right now we are seeing the big booming of the AI right now, and the deep learning and neural network is the core of the AI boom, AI boom we are seeing. But still, neural network is harder to getting started, and there is a reason for that. And Google has been solving that kind of problem for years, and I'll be talking about that. What is neural network? Neural network is just like a function in programming or function in mathematics. So it takes an input and output data. So for example, if you want to have neural networks to recognize the image of a cat, you can put the image of a cat, like a pixel data, into a large vector and do the matrix operations, multiplication and additions, and eventually you would have another vector as an output that has the label such as a cat or human face or flower. So you can train the neural networks to output the results like that. And the image recognition is just one application for the neural networks. You can try applying the neural network to any kind of the problems you have. Like if you have your own gaming server, you can try converting all the user activity logs or player activities log, what items the player has purchased or what activities player has been doing into a vector, and try to train your neural networks to find a certain types of the player, such as is it some spam player or cheating player, or is this be a premium player who could be purchasing more and more items? So that is one of the example of the neural networks applications. So you can try training the neural networks for any applications you have. And it is really hard to estimate what kind of the result you would get from the neural networks for each application. So let me show the very simple example of neural network by using this double spiral pattern. If you take a look at these patterns, it takes two inputs, the x1 and x2, and if you plot those data points in the 2D space, you can easily see that there are two spirals. One is the orange spiral, and another is blue spiral. So for human, it's very easy to tell the pattern in the data set. But how do you instruct computers to classify these orange and blue dots? Do you want to write many if statements with many conditions, checking whether the point is here, the point is in here? You can do that, writing many conditions and if statements, but I don't want to do that. Rather than that, I want to use neural networks like this. This is a demonstration called Playground, where you can build your own neural networks or deep neural networks inside the browser and train it. So here we have the x1 and x2 as an input, and there's an output where you can see how neural networks classify each data points in an orange and blue. And let's start training the neural network. So when you started training your neural networks, initially the neural networks doesn't make sense on the data at all. So it would return an arbitrary result like this. The network thinks this is the area for the oranges, and this must be the area for blue. So it makes so many errors. But if you keep training the neural networks with the training data set and spending much computing times, then you can see gradually neural networks can extract the hidden features or patterns hidden inside the data set. So now you see the training has finished. The neural network is smart enough to distinguish the double spiral pattern, just like humans do. And if you take a look at what each neurons are doing, each neuron is doing a very simple things. As you know, the neurons in the human brain, we have about 100 billion neurons in our brain. Each neuron is doing very simple things. It's get excited or not. So each neuron takes about 10,000 electric signals from the other neurons or the body, like eyes or ear, and decides whether the neuron's going to excite it or not. It's so simple. Just like that, so artificial neuron in the neural networks is getting excited or not by looking at the input. So for example, this particular neuron at the top left corner, it checks whether the data point is in the white area and blue area, and that's it. Drawing a straight line here and classifying the data points into two. It's a so-called linear classification. It's very simple. And other neurons in the first layer is doing the similar things. This neuron is drawing a straight line here and checks whether a data point is in the left or right. If it's in the left, the neuron is getting excited. So it's so simple, but if you have a bunch of neurons, and if you have the multiple layers of neurons in hierarchy manner, then you can see a very interesting things is happening here. For example, the neurons in the second layer takes all the outputs from the 8 neurons and make a little bit smarter decisions on that. Because it can take the output from all the 8 neurons in the first layer, you can make a smarter decisions. If this neuron and this particular neuron and this neuron says these outputs these data, that means there are certain patterns in this data. So just like that, this particular neurons checks whether the data point is in this white round area or not, or this pattern. And if you take a look at the neurons in the third layer, you can see the neurons is getting much, much smarter. And there's a final neuron, single neuron in the output layer. This neuron is smart enough to understand there's a double spiral pattern. And the most important point here is that I haven't programmed anything on these neural networks. All the neural networks usually randomly initialized, and all you have to do is spending many training data, and that's it. So that's the huge difference from the traditional IT systems or programming and the artificial intelligence, specifically neural networks. Neural networks can take a training data and try to find the features or patterns from the data set. So sometimes it can find the patterns humans never seen. So that sometimes the neural networks can exceed the human performance. So that's the reason why we are so excited with the neural networks and the AI boom right now. So by using this technology, you can even have a neural network recognizing this image as a cat or British short hair. To do that, you have to have tens of the neural networks, hidden layers, the layers of the neural networks between the input and output. That is so-called deep neural networks. And if you train the deep neural networks with the hundreds of thousands of the images, you can see that the neurons are trained in a very interesting way. Neurons closer to the input images will be trained to recognize very simple pattern, like these edges. And neurons in the middle of the deep neural networks is trained to recognize a texture or color. And neurons in the higher layer can recognize a certain parts of an object, like a nose or eyes of human face, or tires in a car. Or the neurons in the last layer can recognize the whole object, like a car or a flower or human face. And again, you don't have to program neural networks to work like that. All of these images you're seeing right now is naturally, automatically generated inside neural networks without having humans programming the neural networks. So that's the very basic of the neural networks and why we are excited with the technology. And TensorFlow is an open source library for building this kind of deep neural network by yourself. So Google has been using our own framework for building a neural network and deep learning, but we have decided to open source it. So that's the TensorFlow. We have open source TensorFlow in November 2015. Anybody can download TensorFlow from tensorflow.org. That is the latest deep neural network framework we are using inside Google. And from the initial release, we have been adding more and more features on the TensorFlow. And when was it? It was like 1 or 2 months ago. We just released 1.0. It was, I think, 1 month ago. And the one benefit you could get with TensorFlow is the portability and scalability. So you can just getting started with the technologies by downloading source code to your Mac or Windows, and you can getting started with the TensorFlow sample code. And you will soon find that your Mac or Windows has enough CPU or computing power to train the neural networks to recognize catch your image of a cat or something like that. So you may want to use the GPU server, but single GPU server is not enough. Many people are spending a few days or a few weeks with single GPU server to finish their trainings on neural networks. So people like Google, Facebook, Baidu, or Microsoft, they are all using the tens or hundreds of GPU server running in parallel to do the so-called distributed training. And one benefit you could get by using TensorFlow is that you don't have to think about those scaling out or failover or redundancy when you want to scaling out the trainings. So once you have defined your TensorFlow graph, neural network with your TensorFlow, you can just upload your graph onto the cloud so that the runtime on the cloud can take care of all scaling out and distributions. So you don't have to think. You don't have to build your own GPU cluster by yourself. And also, when you have finished your training with GPU, you can upload the neural network parameters, widths, and biases. That is so-called model. You can copy the model to the devices such as Android or iOS and Raspberry Pi. And actually, you can find the sample code for the Raspberry Pi or Android inside TensorFlow. So you can easily try building your own Android application, which runs the deep learning inside it to do a deep neural network image recognition or any other applications. So last month we have announced the TensorFlow 1.0, which has three changes. Three changes. The one is it's much faster. You can get the 58 times faster speed up when you're running a training on GPUs. It's more flexible. For almost 2 years, TensorFlow only provided so-called low-level API. So when people wanted to learn about TensorFlow, they have to learn the very low-level API, which defines a graph of the computations for defining your neural networks. But now we have the higher level APIs that allows you to write just a few lines of the Python code to define a new deep neural networks. And all these APIs are now stable, so you can get started with TensorFlow right now and applying the technologies to the production projects. And as I mentioned, with the TensorFlow 1.0, we provide the so-called high-level API, so it's much easier to define your own neural networks. And also, maybe some people have heard about Keras. Keras is one of the most popular wrapper for the deep neural network framework, such as TensorFlow. So many, especially for the beginners or data scientists, are using Keras already. So we are going to support the Keras as a standard API in TensorFlow 1.1. So you can choose whether the Keras or the estimator, which is here, the high-level API we provide, to getting started with the technology. So let me show some simple demonstration of the neural network training on the. I'm not sure if the demonstration is working. So here I'd like to show a very simple demonstration of TensorFlow, which can classify a Manhattan, one geolocation is in Manhattan or not, by looking at the latitude and longitude. And to do the training of the neural networks, I'd like to use the BigQuery, which is a data warehouse from Google, to provide the training data set at first. So this is a tool called Google Cloud Data Lab, which is a Google Cloud version of the Jupyter Notebook. So if you're a data scientist, you already know about the Jupyter Notebook, which is the industry standard, the GUI tools for the data analytics. And we have combined the tool with the Google Cloud so that you can easily write your SQL for BigQuery and execute it inside the tool by selecting the cell and executing the query in it. So now we are executing the query inside the tool. The query is actually running in the US data center right now. And now we are trying to read all the first 15 rows of the NYPD collisions data set, which records all the collisions happened in the New York cities. And I think it's taking so long time. Maybe I have to restart it. Let me execute it again. Because this is a live demonstration, so I think sometimes it doesn't work. Yeah, while we are waiting for the result, what we are going to do is that, so we will be having the pairs of the latitude and the longitude as well as the borough, like the Manhattan or Bronx or the other borough. And by using that data as a training data, we want to train the neural network. But it's not running, sorry. Is it connected? Sorry about that. Yeah, this sometimes happens. I was running this again and again and again in that room, but now it didn't work. Sorry. So maybe we can try this later. But my point is that just getting started with TensorFlow is very easy. You can just write a few lines of Python code like this. So you can just input TensorFlow like this, and here we are defining the neural networks. So this is the so-called high-level API or estimator API of neural networks, of TensorFlow, where we are defining the 4 hidden layers, and each layer has the 20 neurons inside it. So this is the deep neural network you already have. You don't have to write tens of lines of Python code to define neural networks. You only have to write like 4 lines of code. That's it. I think it's still running. So after defining your neural networks, you can plot how the neural network can classify the Manhattan, each data point is in Manhattan or not by using the matplotlib. Yeah, so that's the demonstration I wanted to do. So maybe I have to skip it. But anyway, I'd like to move on to how we discuss how the Google has been using TensorFlow for implementing our services. So we are using the TensorFlow on the over 100 production projects. For example, if you are using Google Search, you have been already using the TensorFlow and deep learning every day running on our Google data center, because the RankBrain is the deep neural network, the algorithms we are using for the Google Search. Google Photos uses deep learnings for classifying the images, such as dogs or human face, and you don't have to put any metadata or tag on it. And Smart Reply in the inbox can show an option for replying to the messages. So you don't have to type the reply by yourself. Instead, you can show the options how to reply to the messages by looking at the context of the messages. And now it generates the 10% of all responses on the mobile. Google Translate recently introduced a new neural machine translation model that provides the significantly better accuracy and fluency on the translation. A DeepMind team of the Alphabet company has introduced the deep neural network model in the Google data center to automate the cooling resource allocations in our data center, and that model was able to save the cooling energy up to 40%, and we have improved the PUE up to 15%, and this is a significant cost savings for us. So now in Google, we are using the deep neural networks for over 100 production projects. And now TensorFlow is having a growing community and ecosystem now. It's the #1 popular repository for the machine learning on GitHub. As you can see on this graph, we have several other deep learning models and frameworks such as the Keypie or CNTK, AUCNET, Torch, Theano, but TensorFlow is the most popular deep learning framework. And we have many the enterprise customers such as Airbus, ARM, or DeepMind, Dropbox, eBay. They're all using TensorFlow right now for building their deep learning. Qualcomm recently made an announcement that they will support TensorFlow natively on the Snapdragon chipset so that they can. It's still running. Sorry. I tested like 5 times. So by having the Qualcomm Snapdragon chipset supporting TensorFlow natively, you can see the huge difference on using the deep learning inside smartphone. The right side is the, it's not working again. Oh, it's working. Yeah, it's working. So the left side is the deep neural network running on the smartphones when you are running it with the CPUs. So when you are running the deep neural networks with CPU, like an ARM CPU core on the smartphones, it takes about 2 seconds to recognize one object, like a banana or teddy bear. But if you use the Hexagon DSP, that is a coprocessor running besides running next to the CPU, and by having the TensorFlow natively supported with the DSP, you can shorten the latency into the 100 milliseconds or 120 milliseconds. It's like 10 times or 15 times faster. And also the battery consumption is much, much lower. So if you want to bring your neural networks applications into production as a smartphone applications, you need to use the DSP rather than CPU. So that's the one benefit you could get with the ecosystems TensorFlow provide. And now, it's a very interesting thing is happening right now that everyone has started using the TensorFlow, even the people who doesn't have any ML expertise or data scientists, like the cucumber farmer in Japan. They are the cucumber farmer in Japan, and they have a son who quitted his company 2 years ago and started helping his parents cucumber farming. And he found out the sorting cucumbers are the most tedious task for all the farmers. His mother spending 8 hours a day for classifying the cucumbers into 9 different classes. And he didn't want to help that. He didn't want to inherit that tedious task. So what he did is downloading TensorFlow and build his cucumber sorter. And he spent about $1,500 by using Raspberry Pi and Arduino. He made his own robotics sorter. The Raspberry Pi running TensorFlow takes a picture of the cucumbers and classifies the TensorFlow into 9 different classes. And he took 9,000 photographs of the cucumbers and putting the labels chosen by his mother. And the initial prototype was able to get the 70% accuracy. That is pretty high. And also, this is another interesting use case of TensorFlow, which is a fried chicken nugget server. There's a startup called RT in Japan. They are a manufacturer of the robot arms. And they are not expert for machine learning or deep learning at all. And they had an intern student who was so interested in trying out TensorFlow. So the company let the student spending 2 weeks to build this demonstration. And he made this within 2 weeks. So he took, actually, the company's CEO actually cooked the hundreds of the chicken nuggets by herself and took the photographs of the hundreds of chicken nuggets and trained the TensorFlow model by using those photographs. And they were able to build this demonstration in 2 weeks. And there are so many other funny use cases of the TensorFlow, like the sorting garbages. This is a garbage can which has a Raspberry Pi and a camera that sort out whether the garbage could be recyclable or not. So all of these interesting demonstrations and ideas has created within the last 6 or 12 months. And now the companies, enterprise people are trying to bring those technologies into productions by using cloud machine learning engine. As you can see, we have been seeing, there are so many interesting ideas happening in the ecosystem and community of the TensorFlow, but the hardest challenge is the computing power. If you try the deep learning by yourself, you will find that you have to buy a bunch of the GPU servers, like tens of them, to train the neural network model for the production use cases. It takes a few days, a few weeks. So we have started to using our Google Cloud to implement the distributed training on of the deep neural networks. Google Cloud is so-called the data center as a computer. That means you can use the tens of the thousands of the machines in a single data center building as a single computer, massively powered computer. And all of those computer nodes are connected with the high-speed networks. It is called Jupyter networks. We are not using the commodity network switches and routers such as Cisco or Juniper. Instead, we are hiring many network hardware engineers and designers. And we have been building and designing our own hardware network switches from scratch that can hold up to 100,000 ports of 10 gigabit Ethernet. That yields 1.2 petabit Ethernet. And we even design our own ASIC or specialized chipset for running TensorFlow, deep neural network calculations. That is called TPU or Tensor Processing Unit. And rather than using CPU or GPU for the prediction or training for the neural networks, using TPU, you could get a 10 times better performance per watt ratio. That means by using Google Cloud, you can provide your neural network service at significantly lower cost. And what's the end result of using those specialized hardwares? The result is much faster, the faster training. For example, if you train your own ImageNet model on Google Cloud by using 50 GPUs, you can get 40 times faster training times. And RankBrain is much faster. You can get 300 times faster training times. So while people are waiting for training of neural networks for a few days or a few weeks, the engineers in Google can train their own networks within like tens of minutes. If he or she goes to lunch and going back to the office, then the training is finished. So that's the significant difference from the Google and the other company. And now we are commercializing, externalizing the technologies as a product called ML engine or cloud machine learning engine. That is a fully managed distributed training or prediction service. So you can just define your own neural networks with TensorFlow and upload it to the cloud so that you can access to the tens or hundreds of CPUs or GPUs on Google Cloud just for 1 hour or maybe a few hours to finish your training. So you don't have to build your own high-speed GPU cluster by spending millions of dollars. And now ML engine has already have several success stories with the enterprise users such as Airbus, AXA, SMFG, AUCNET. And I'd like to show some of them. For example, Kewpie is the one of the largest food manufacturer in Japan. And the one challenge they had is the classifying the batch potato cubes on the belt conveyors on the food factory. And if you spend $100,000 on the classifying for the classification machine, that doesn't solve the problem. So they have been using human eyes to watch out the potato cubes with the bad shapes or bad colors. So they decided to try out the TensorFlow. You need to view permission. Sorry. This is the actual belt conveyor they have in their factory, where they are deploying the TensorFlow-based batch potato detector. So this is the belt conveyor. And as the belt conveyor have any batch potatoes, it rings a bell, so that the people, or the operator on the belt conveyors can notice that there should be the batch potato is coming in a few seconds. AXA is another interesting use case for the TensorFlow and the ML engine. AXA is, as you know, the one with the largest global insurance firm, and they have been trying to find the large loss cases in the car accidents. Large loss means the car accidents which requires over $10,000 as the insurance payment. And they have been trying at random forest algorithms for finding those the large car accidents by looking at the drivers, the attributes and the properties, but the accuracy was not so great. But by using a TensorFlow and deep neural model, they were able to get the much higher accuracy, up to 78%. So they're putting all the 70 different input features, such as the location of the driver's address, or what's the past accident history of the driver. They are putting everything, all of those driver attributes into a vector and having the neural networks trained based on the past result. Lastly, I'd like to show the demonstration of the AUCNET. AUCNET is a real-time car auction service in Japan. They have the 30,000 used car dealers as members, and in 1 year, they handle over 5 million used cars. But you have to take 20 different images for each car, and human operator have to classify all the 20 different images, like it's a handle, or it's tire, it's a seat, and it takes 5 minutes for human operator to classifying those. So instead, they built their own used car classifier by using TensorFlow and ML engine. Oh, sorry. So by uploading those car images to their systems, the systems can start classifying the parts. If it's a tire, or if it's a steering wheel, if it's a panel. And until now, the human operators have to classify all of those parts of the cars, and also he or she have to find out what's the car make, what's the model of the car, and identify it and input into the systems. But now, you don't have to do that. All the classification has been done automatically by using the deep neural network model. So systems can tell by looking at the 20 different images, this must be a Toyota Land Cruiser with the exact car model. And it can also estimate the car price, used car price. So that if you have the gas station around you, and you could put the digital signage and the web camera on it, so that you could have a digital signage showing that if you sell your car right now, you could get the $10,000. And as you can see, the deep neural network model can tell the subtle difference between the front seat and the rear seat. So it's as accurate as human eyes. And by using ML engine, they were able to save the training time so much significantly. So rather than using a single CPU or GPU for trainings, by using ML engines, they were able to increase the training performance up to 86 times faster. So that's the solution we provide for the deep learning. So we provide TensorFlow as an open source tool, and we provide the whole of the other suites of the products that supports the TensorFlow. And also we provide the big data solutions such as BigQuery, Cloud Storage, Dataflow, so that all the processes you need, like pre-processing, ETL, or the training of the neural networks, and running a bunch of GPUs on the cloud, is provided as the cloud services as well. So that was it. Thank you.